Mr. Sonnenberg here. Today what we're going to be talking about is physical change. So, not physically changing ourselves, but physical change. So when you think of physical, we think of things like, I don't know, like when I first think physical, I think maybe someone's body or something like that, right? But that's not exactly what we're talking about. So what we're actually talking about with physical change is we're talking about a substance changing in form, but it doesn't change in chemical composition, which means that a new substance or chemical or form isn't taking place. So examples, if you just take a look at the pictures here, if you just take a look at the ice melting here. Oh, nice. My arrows suck. Anyways, take a look at the ice melting. Well, that's ice. It's not changing in chemical composition. What's ice made of? Well, it's made of water. And actually, speaking of water, I need some water right now. I have lots in the lake right beside me, but I'm not going to drink that. Ha ha ha. I'm not. But anyways, so the ice is melting. Now you can see the water there with that ice melting. You can see it. But then you see the solidified form of water, which is ice. Now, same thing with a popsicle. And that's the worst thing. I hate wasting popsicles. I hate it. And hate's a strong word. I shouldn't use that word. But I dislike wasting popsicles. And sometimes they drip down my hand and they get sticky, and I try to wash my hands and I miss a spot. But what's happening is the popsicle didn't change. Because it melted, it doesn't mean it's not the same substance. It's the exact same substance. It's just in a different form. And that's important to realize that in a physical change, it just changes form, not chemical composition. So a couple other things that happen. If you take a look over here, leaves change in color. That's actually a physical change, because the leaf, it's not changing. It's still the same leaf. It's just a different color now. And then also things like chlorinated water. Okay, chlorinated water is also a physical change. So basically, what we have is that water is still water, still same composition. It's still uniformly scattered, its particles and stuff. But because the additive of chlorine, we would say, well, it has a different taste. Well, it does, because it has chlorine, but it's still the same composition. That chlorine is it's still water. So if it was to freeze or something, it's still water. And then again, here we just have tap water as well. Well, water can freeze, it can melt, it can evaporate, it can sublimate, it can do all those things. So I'll just show you that stuff in a chart here. So if you just take a look at this first picture, we have ice. First thing up, we have ice right here. Okay. Oh, I'm struggling with this pen. Then we have water. Oh, still struggling. And then we have water vapor, which is basically, water vapor is the evaporation of water. So if we heat it up, if we cool water below zero, we form ice. If we heat water over 100 degrees Celsius, then what we do is we create water vapor, and that goes back to our physical properties. Okay, well, ice is hard, water is wet, the particles are moving around, the particles are closely packed together in ice, a little bit farther apart in water, and then even farther apart in the gas state of water vapor. But what's happening is, if we add heat, then what we do is we hit water's boiling point and it starts to evaporate, right? And so then that turns into water. And then its freezing point is zero. Again, physical characteristics, physical properties of water. Now, oh, excuse me. If we look at this interconversion of states diagram, basically all that, it's a fancy word for saying, and I'm just going to talk about water, is that when water is a solid, if we're going to turn it to a gas from a solid, then we call that sublimation. We skip the liquid stage. But if we go from a solid to a liquid, we call that melting. And so melting it's just basically a ice cube. But this is going to happen pretty soon in the spring here, right? I look out at the lake, it's frozen right now. Things are starting to melt. It was +8 today outside, so I didn't even have to shovel the snow in my driveway because it just melted, which was perfect. And so that's the changing of states, and I think you get that. And so we take a liquid to a solid, then it's freezing again, and then if we take a liquid to a gas, we call that evaporation. But have you ever seen a window, and on your window you actually have drops of water in the winter? So it's cold outside, it's warm in your house. Well, I hope it's warm in your house, but it's warm in your house and you see drops of water. Well, what that is that's water vapor being cooled by the temperature of the window. And because that water vapor inside your house is being cooled, then what it does is it starts to form what's called condensation, so going from a gas to a liquid. And that condensation actually is going to form on that surface, and it's going to turn that water vapor back into liquid water. So anyways, that is physical change. Oops. That's physical change. So you'll have to understand the differences and some examples of physical change. You have to understand them from a list, be able to identify them. Hopefully this has helped. We'll try to keep these screencasts nice and short for you. Okay, see you on the next one. Bye.